So when we talk about climate change scientifically, I would say there are two components. One is the natural variability, one is human-induced component. So we have to bear this in mind. But under the Climate Change Convention, we can't control anything about our nature, but we could control our human activities. That's why they are very much focusing only on the human-induced aspect. So under the Climate Change Convention, when they talk about climate change, what they mean is only the human-related activities or human-induced activities. So they are, because we cannot control our nature. Yeah, no way. You cannot control volcano eruption. You cannot. About 150 years ago, an Irish scientist called John Tyndall, he has already studied some of the properties of the greenhouse gases, their absorption properties, infrared absorption properties. When I talk about ozone layer, I refer to the ozone layer at the stratosphere, from 15 to 50 kilometers away above the surface of the Earth. I'm not referring to the surface ozone or tropospheric ozone below 15 kilometers. The Climate Change Convention doesn't control ozone, even though it's a very strong greenhouse gas comparable to methane even. Yeah? But because it's not direct emission, difficult to control. Yeah? And I think that Dr. Daniel's group has done a lot of work on this chemical reaction, photochemical smog, it produced under the sunlight and all these things. All these implications for our climate. It also points out to the fact that the greenhouse gases have different lifetimes. Human beings have a lifetime. My biology professor in China told me that if we are not subject to any stress or environmental stress or whatever, we could live at least 130 years. At least. Is it true? That's it? Biology, according to them. But atmospheric gases also have lifetime just because of the fact that they react with other species. For example, one of the very strong sink for ozone is the reaction with the species called OH radicals, hydroxyl radicals. 90% of ozone, in fact, is destroyed by reaction with OH. Nobody talk about this chemical sink. We only talk about physical sink, forestry, absorb carbon dioxide. To some extent, we talk about biological sink. Soil can be a sink for carbon dioxide and others. But chemical sink, we have not talked too much about at the moment. 20 years ago, when I was working at the climatic research unit, many public asked us, was climate change real? At that time, we said we could not be sure. Let us wait 20 years later. Let's look at the longer trend. Because when you talk about climate, you talk about the longer trend, longer data. 20 years, 30 years, 50 years, 100 years, even millions of years sometimes. So this is what we need to know about the climate. One cannot talk about today's weather. Today we have flood, not necessarily due to climate change. Could well be or may not be. But if you look at a longer period of time, then we could see a trend. Then we could conclude that, okay, climate is changing. And we have been doing since the last 20 years. Of course, I mentioned IPCC Nobel Peace Prize in 2007, just for, together with Al Gore, for their efforts to build up and disseminate greater knowledge about man-made climate change and to lay the foundation for the measures that are needed to counteract such change. Refer to the negotiation process. Because of IPCC's contribution, based on IPCC's findings, we have this negotiation process. We have this Kyoto Protocol to control emissions, and we have many mitigation measures and adaptation measures, to address the adverse effects of climate change as well. And also, at least in the northern hemisphere, that the 20th century was the warmest century, for the last 1,000 years. Very difficult to be explained by external forcing. Very unlikely due to the known natural causes alone. This is the conclusion of IPCC. Of course, since IPCC, we have this latest report released by NOAA, produced by the American Academy of Science in 2007. They have, in fact, many also participated by hundreds of scientists. Malaysia, how many degrees C temperature increase is good for Malaysia, or to be regarded as a dangerous limit, upper limit, for climate change. So our scientists need to study this. You cannot simply listen to IPCC or simply listen to other outside bodies. we have to have our own position, our own scientific position. This is a global temperature record produced by UEA, my former research institute, Climate Research Unit. Dr. Phil Jones, director now, has been a long time climatologist. He was one of the very first few ones to crack this temperature record based on marine data and land data. As you can see, the red color one shows the temperature anomaly. Anomaly means that you always compare with a long time mean. In this case, I think the mean is 1961 to 1990. And also the project temperature, according to climate models, shows a significant increase in temperature. This is, this data extract from a paper published by Dr. Yap and colleagues. Dr. Yap Kok Seng, who is the current Director General of the Malaysian Met Service. So we always talk about radiative forcing of climate change. Means that the difference is the balance between the incoming solar radiation and the outgoing infrared radiation. How much the greenhouse gases have absorbed the radiation. Through this process, we could find out the so-called radiative forcing of climate change. In fact, IPCC has already assessed that. As you can see, carbon dioxide, is a major, show the major greenhouse gas because it has the major, radiative forcing. And methane, nitrous oxide are also there. It's interesting to see that the ozone depletion would cause a cooling of the climate. Some of the aerosols in our atmosphere due to pollution could have a cooling effect and also a warming effect. So they play a double role sometimes. Yeah? So overall now we are at the level of this 375 carbon dioxide equivalent. Why not carbon dioxide? Why carbon dioxide equivalent? Because we take into account of the equivalent effect of methane, nitrous oxide and other greenhouse gases. That's why they put everything into the same common term. For example, methane is 23 times higher than carbon dioxide, molecule per molecule, than carbon dioxide. So we have to multiply by 23 times. 1 ton of methane is equal to 23 tons of carbon dioxide. So when you add all this up, you've got this common unit called carbon dioxide equivalent. Yeah? Interesting to see the cooling effect and the warming effect of some of the parameters in the atmosphere. As air and ocean temperature increases, of course, we witness the impact of climate change. Scientists are able to project the impact of climate change as well through climate models and highlight below. Melting of glaciers and sea ice globally due to global warming. Ice melting is everywhere, I would say, throughout the world. If sea level rise to a number of meters, Malaysia also would have lost some land. I'm sure the NRE, under the national communication, we have studied this very clearly. It is a very direct effect, actually. That's why it is easier to study in that sense. One could easily estimate how much land would have lost because of the rising sea level. Yeah, as you can see from this animation here. So Malaysia become much thinner, the West Malaysia become much thinner. Okay. Climate change also change the rainfall patterns, wind patterns, temperature patterns, storm tracks. How would this affect Malaysia? So we need to study. But Malaysia has been very lucky because we are not so much under the tropical cyclones belt, compared to Vietnam and Philippines. Typhoon always hit Philippines first before they hit Vietnam. So I always told my friend in Vietnam, we are lucky because we got an early warning system from Philippines. And then a few days earlier, so they could prepare for your disaster, reduction or management. But Malaysia has been quite lucky, I would say. Yeah? We are not so much under the impact of climate change. For example, this typhoon Cassandra in 2009 not only hit Philippines, Vietnam, but also Cambodia and Laos. At the same time, actually. It happened. I checked the record. It happened many times before, actually. Yeah. So you will see scenes like this when typhoon hit Philippines. You will see scenes like this. This is a Cassandra also from Vietnam. This is Cambodia, almost the same time. This is Laos. Just pick that as an example. That's why Malaysia always suffer from drought. We all know about this 1997 drought haze issue because of El Nino. A Spanish name, little boy. In fact, scientific data indicate that the El Nino year's frequency has been increasing. In some years, even the spike, the height of the spike means the intensity, have been increasing. You cannot say so much about the La Nina, the blue color one. Even though now, we have floods in Thailand, we have flooding in Thailand everywhere because of La Nina. This ENSO process, ENSO means El Nino and La Nina, there's a natural process. Perhaps the climate change will have affect those natural variability, because the climate change could have masked, mask those variability, and vice versa. Scientists need to study this. How much is attributed to climate change caused by human activity? How much is actually purely, due to the natural variability? So this is one thing we need to study more. Yeah, of course, this case because of El Nino, Indonesia. I don't need to go through this. All this pollution been created, aerosols, ozone, different colors, so different things. Yeah, and of course, you see this very common. Only not so long ago when I came back from Australia, I saw this haze issue actually a few weeks ago. Economic cost, social cost, is enormous because of these forest fires. In 1997, for example, I think they cost about $3 billion according to some estimation. What about human life? How could you put a cost for human life? Loss of biodiversity, loss of productivity, things like that. So finally, we have this ASEAN agreement on transboundary haze pollution. It's signed. I think we entered into force in 2003. I'm sure Gary could share more information with you. Last year, we was quite a strong El Nino year. I was in Laos at the time. I was an advisor for the Mekong River Commission for the climate change project. I saw the very low level of water, in the Mekong River. In Malaysia, we only get drier when we have El Nino years, which could be masked by, as I say, human-induced activities, climate change. So this is what IPCC has said. And many decrease in rain over land, in tropics and subtropics. Projected that rainfall patterns would increase very lightly at high altitudes and decrease very lightly in most subtropical land areas. But Malaysia, according to what I have read from Dr. Yap's paper, the rainfall pattern doesn't seem to have changed too much. No significant trend. Even though the models, climate models project that they would have an increase in the future. But once again, this climate modeling, we have to be very careful. They are using a certain scenarios, then I think the scenario, that was an IPCC 2001 scenario. Already so many years outdated, I've been suggesting that we need new scenarios. In fact, the IPCC actually is looking at the new scenarios now. 10 years ago scenario and 10 years later, they are quite different. I'm pretty sure that when the new scenario released by IPCC, there will be some changes in the modeling exercise in Malaysia. IPCC had done a certain projection based on their modeling. They predict the temperature would increase between 1.8 on average to 4 degrees C by the end of this century. This, of course, depending on this concentration. The lower the concentration, of course, you have the lower temperature increase. The higher the concentration of greenhouse gases, you have a higher temperature projection. It is also scientific. Yeah, it's nothing, of course, based on different scenarios. These are the different A2 and B1. They are different economic activity scenarios. Just like the Malaysian scientists have done, based on the scenario, they do a certain projection. And 20 to 30% of higher plant and animals are high risk if our change in temperature is between 1.5 to 2 degrees 5 C over present. That's why they use this figure, as an indicator for, red light. 2 degrees C is the red light, sort of a temperature. We should not go beyond. And Article 4 commitment also specifies that the developed country parties should provide finances to developing country to help them to implement the convention. It's all in the commitment which they have signed. Of course, Cancun Agreement have this so-called financial package, $30 billion for the period 2010 and 12. And also maybe more $100 billion per year by 2020. In fact, these are many times less than required, I believe. Some UN agencies have done some study. They found that they need hundreds of billions of dollars to address this issue. It's a lot of money when you think about they drop one bomb in Iraq or Afghanistan, $1 billion one bomb. I don't know how many bombs they drop. in Afghanistan or Iraq, you know, it may not be so much money. When you look at the financial crisis, you know, America want to rescue the banking system. You know, not so much money by comparison. Yeah? Carbon intensity is different from carbon emission. When we talk about carbon intensity, means that we measure this in terms of GDP. Yeah? Carbon emission, just carbon emission, carbon just so many times. But carbon intensity means you measure this intensity in terms of GDP. Our Prime Minister pledged 40% of reduction. So I'm always wondering this about, why 40%? Why not 41%? Why not 42%? Why not 50%? Why not 30%? So what are the basis for this 40% maybe? And now it has done some assessment, I don't know. It reminds me of a case in Bhutan. When I was in Bhutan a few years ago, I advised them on their environmental law. There was a clause saying that no factory should build 50 meters from the residential area. So I asked my Bhutanese colleagues, why 50 meters? Why not 51? What if they build 51 meters? So it will be illegal. If they build 49.9 meters, still legal, still within 50 meters. So what is the scientific basis for this buffer zone? You have to base on science. We have to do the meteorological measurement, look at where the wind is blowing, to which direction. Then we can able to, do a certain sort of law, a limit, legal limit. So you cannot fit all. If a factory is built in a certain area, there must be a certain prevailing wind, blow downwind all the time, and the upwind will be much more cleaner. So the mitigation options, I think this is the most important slide, of my lecture, I would say. You must practice sustainable development policy in every sector. Industry sector, energy sector, land, water, forestry, agriculture, mining, transport, technology, human health, and social services. If you could do that, you will be very successful. Yeah, in terms of mitigation, in terms of reducing emissions. Not only on paper, we have to actually do it. Yeah? Not only say that Malaysia is practicing sustainable development, but we have to actually do it. Yeah? To study the whole planet airshed as a whole, rather than spot sampling here and there, so that we can look at the meteorology, we can look at the impact, we can look at how the sea breezes come and go, how far they go, how high they go, how much it disperses the pollutants, things like that. So we need a group of experts to undertake those studies, perhaps maybe our Academy of Science to pick that up also, including green building, school activities, public awareness. From what I recall, oil palm waste, zero waste from the oil palm industry in conjunction with Sindabi, and also the cooperation with EOC, doing a lot of coastal zone management. She just talked about this to me this morning about some of the climate change activities which they are going to initiate. So, in cooperating with the Faculty of Engineering and Built Environment, they are doing the eco-housing as well. Thank you so much. That's all I'm going to say. Thank you.